Hello guys, welcome to Small Samuel Maths tutorial. So in this video we're going to talk about the initial value problem and also the boundary value problem. So let's start with the initial value problem. Whenever they say calculate the initial value problem whereby it's in the second order linear equations, in the simpler terms they want you to find the unknown values from the complementary function. Remember that in the differential equation of the second order linear equations, we do what? Most of the time we start, whenever we find the complementary function, we're going to follow all those three steps and then we check the case, and then after we are going to find what? The complementary function. And when we know that our complementary function, it will either be C1 e to the exponent of something, right, and then C2. So in simpler terms, in the initial value problem, they want us to calculate those unknown values, which is C1 and C2, right, for what? For the complementary function. So it means we are still going to follow all those steps that we talked about in the first video on how to find the complementary function. If you didn't see that video, I'm going to leave a description below. So I prefer you should go to start with it so that you cannot get confused whenever we talk about the initial value problem, right? So now let's start doing the examples of the initial value problem. So the first question says, solve the initial value problem given y to the second prime plus y is equals to 0, and the points its y is to 0 is equals to 2, and then 1 to the first prime of 0 is equals to 3, right? So whenever you're given something like this, find the complementary function first. So how do we find the complementary function? We know finding the complementary function, we're going to write, the first thing that we're going to write is what? It's our homogeneous equation. What is the homogeneous equation? The homogeneous equation, it's y to the second prime plus y, which is equals to 0, right? Then after writing your homogeneous equation, now you're going to write what? The auxiliary equation. What is the auxiliary equation? The auxiliary equation is going to be d squared plus 1, which is equals to 0. Remember, we follow all the steps. So like I said, if you are new, you don't know anything about how to find the complementary function, there is a link in the description below. Kindly go to check it before you can go through the initial value problem, because you're going to find it difficult to understand this. So now we are going to solve for d. Remember, also in the auxiliary equation, someone can write m squared plus 1 is equals to 0. You're also correct, right? So now we're going to find the values of d. So we can see that we're going to have d squared is equals to negative 1, right? So whenever we have d squared is equals to negative 1, we are going to divide everything by what? By d, right? By the square root. Then the values that we're going to get, it's going to be, let me write it this. We're going to have something like this, right? So we know that whenever you plug this in your calculator, it's going to give you error. But then as it gives you error, remember that now from the first video we talked about the imaginary numbers, right? Or the complex numbers. So we know that our d is going to be equals to I, right? Whereby we have plus or minus here. So our d is equals to plus or minus I, right? So after finding these values, remember you can write it them like this, which is 0 plus or minus I, right? And then now we did find our auxiliary equation, and then we know that our alpha is equals to 0 and the beta is equals to 1. Like I said from the first video that We don't care about the sign, we just take the number the way it is. So now we can see that we have case what? This is case 3, if I'm not mistaken. Yes, it's case 3, whereby the complementary function is going to be e to the power of alpha multiplied by x into c1 cosine of beta x plus c2 sine of beta x, right? We are going to have this equation whereby we're going to have e to the exponent, our alpha is 0, therefore 0 multiplied by x into c1 cosine of what is our beta. We can see that our beta is 1, so therefore just going to have cosine of x plus c2 sine of what is the beta, it's x, it's 1, therefore it's going to have x, and then anything to the exponent of 0, it's what, it's 1, right? So meaning this is going to cancel out, therefore we'll be left with 1. So meaning the final solution is going to be plus c2 sine of x, right? This is our yc, which is known as the complementary function. Now we are done finding what the complementary function. So, but the question said solve the initial value problem, and we are given the points here, right? So meaning now we need to find what? That's where the questions come. Now the question says solve the initial value problem in simpler terms. Find the unknown values, which is C1 and C2, right? So how are we going to find those values? You can start by saying for y is equals to 0, for y into 0, whereby is equals to 2. Therefore, where we see y, we're going to replace it with 2, and where we see x, we're going to replace it with what? With 0, right? So yt, we're going to replace it with 2, and then we're going to have c1 cosine of, where we see x, we said we're going to replace it with what? With 0. Therefore, we're going to have cosine of 0 plus c2 sine of 0, right? So now if you plug this in your calculator, the cosine of 0, you're going to get 1. So meaning we're going to have c1, and when you plug sine of 0 in your calculator, you're going to get 0. So we'll be left with c1 is equals to 2. So we have already found the first unknown value. Now we need to find what? C2. So how are we going to find C2? Remember, we're not done. We already used these points. So now we need to use 4. Let me do this. Sorry guys. Then now we're going to use 4. Let me start here. For y to the first prime of 0, whereby is equals to 3, right? So you can see that we don't have the first prime here. So we're going to take the complementary function, which is c1 cosine of x plus c2 sine of x. After writing it down like this, because we can see that we have the first prime, so meaning we need to differentiate this complementary function so that we can have the first prime, then we can be able to substitute. So now when we differentiate this, we're going to have y prime is equals to the derivative of course it's negative sign, so we're going to have negative c1 sine of x. Therefore the derivative of sine, it's what? It's cosine, positive cosine. Therefore we're going to have c2 cosine of x, right? So now we have that equation. So now we can be able to substitute. Where we see the y first prime, we're going to replace it with 3. Where we see x, we're going to replace it with 0. So we're going to have 3 here minus c1 sine of 0 plus c2 cosine of 0, right? So therefore, we're going to have 3. And when you plug this in your calculator, for sine of 0 is going to give you 0, and for cosine of 0 is going to give you 1, right? So therefore, we are going to have our C2 is going to be 3, right? So now you can see that we found those two unknown values. So let's write them correctly. So therefore, our yc is equals to, our c1 is 2, therefore we're going to have 2 cosine of x, what is c2 is 3, therefore plus 3 sine of x. Then we are done solving the initial value problem. This is how we solve the initial value problem. So you can do these examples here that I wrote. So if you get stuck somewhere, kindly leave a comment behind. I will be able to help you. So yeah, we are done with the initial value problem. So I'm going to upload another video for the boundary value problem, right? Because I don't want these videos to be too long. Thank you. So let's not forget to subscribe and like if you did find this video helpful.